Okay, thank you. So welcome. I'll present to you new ideas that we're working on at OrCam and how we believe they're going to impact society. And places like this and events like this really show where technology is going and where we're going to do with it. Some of it is scary, and there were some questions in the previous session. But some of it is very exciting because it's happening and things are happening, and people we want to be better, we want to be smarter, we want to do more. And it's not clear how to do it and how to do it in a constructive way. Okay. So, and I'm going to talk about some of it like that now. I'm going to start with something which is a bit of a cliche, but there's a different spin to it. So 340 years ago, Isaac Newton said, "If I have seen further, it is by standing on the shoulders of giants." Now, nowadays, we all see further, even further than him, right? And we can see further because as a species, we learn to communicate. And part of our communication skills enables you and me to learn from him, right? You never met him, but you can still learn from him because you can read, right? And if you couldn't read, you probably wouldn't be standing here today because we live in the information age, and information is available as much as you want it. You know, people even talk about there's too much information. It's confusing, right? It's too much for us. Our brains were not wired for something like this. And this ability to read is crucial. Now, we take it for granted, right? Because if there's anything you don't know, you pull out your phone, you learn about it. But there's quite a few people who cannot read. And I'll give you one story. And this is the amazing story of Sarah Scott. And she's a British young woman. She was going to class. She was 18. She was sitting in the class. And she was reading something to the class. And all of a sudden, she couldn't read. And about an hour later, she couldn't speak. And a few hours later, she couldn't walk. She was paralyzed. And it turns out that Sarah suffered a stroke. And it's not common in the age of 18, but it happens. I met Sarah 6 years later. In those 6 years, she learned to walk and to speak. But unfortunately, the stroke destroyed her visual cortex, so she cannot read. So by that stage, Sarah is 24, young, clever, energetic, motivated, charming woman that cannot read. Now, what can you do if you cannot read? Right? Your options in life are very limited. So she heard about our technology, and she heard that it can let her read. And we met in London, and I told her, well, when you come, bring something you want to read. And we met, and she brought the letter with her. And I told her, well, put these glasses on, hold the text, and point to it, and I'll read to you. And as she was doing it, I pulled out my phone, and look at this. Oh, wonders of technology. Sorry, let's try it this way. There we go. Yeah. Audio? I can hear it here. Let's see. Sorry about that. This is high tech. Anything? Maybe this? I don't know. There we go.
It's really good.
Right on
has
time.
received your signed declaration.
Right.
Failure to return the signed declaration within 20 days will result in the support being removed and your application will be closed. If you have any
So she's
queries
reading the
once
letter.
you
It's a
have
letter about the
returned your
disability,
signed
apparently.
declaration, please
And
contact
the device reads
Access
for
to
her.
Work
And she was
Maintenance
waiting for
team
6
on
years to read.
02084630590
read this letter. You can see the
1600
mother, and they realize, wow, I have a new lease on life.
It's just like, I didn't
Yeah.
pick you for a male voice, but apparently.
No, it's really good. That's perfect.
It's perfect.
Yeah.
And she just took the device, put it on, and it works for her, and it does whatever she expected to do, because it's a very, very clever device. Maybe we will have more audio, so hopefully it's not going to be so annoying. And this is something remarkable, right? Because nowadays we can build a device that is so clever, it fits with us. And we want to wear it, and we want to have it with us. And we are using wearables, right? I mean, people have been doing it for a long time. Shoes, for example, right? You want it to fit, and it has to fit, and it has to do the things you want it to do, and not be a burden. And I'll talk a bit about it further. And in OrCam, we're changing the world by giving people the information they can no longer perceive. Or maybe they never perceived it. Or maybe they didn't realize they want to perceive it. Now, Sarah is not alone. Like Sarah, there are 26 million people in the world who suffer various brain conditions like aphasia. More than that, there are people who were born without the ability to read, or comfortably at least, right? And this is dyslexia. And it's very, very common. It's very prevalent. And they talk about 10% of the people and 3% with severe dyslexia. As you can see, a lot of them did pretty well in life, which has interesting aspects. But it's a lot of people who don't like the physical act of reading. And one of the amazing things of what technology we did is we made reading a technicality. And of course, if you think about people who can't read, you think about people with visual impairments, and there are hundreds of millions in the world. And they have various, and these are not blind people. Blind people are a very small fraction of this number. But when you think about blind people, let's think about what, if you want to help a blind person, so reading is important, but what else? What else, right? You want something to help you through your life without the use of your eyesight. So a blind person or visually impaired, right, wakes up in the morning and they want to get dressed. They want to pick the colors of the clothes they wear because they want to look nice. Then they want to get to work, but they can't drive, so they're going to be walking and they want to be crossing the street, so they want to know if the cross light is red or green. They want to navigate the ways on the street. If they take a bus, they want to know which bus it is. If they want to stop in a store to get something, they want to find the store. They want to find the door to the store. Once they're in the store, they want to find the product they're looking for, right? And if they came in for a headache tablet and they're holding this box and they want to know, is this really a headache tablet, right? I want to put something in my mouth. And when they want to pay, they want to know how much money they're giving, how much change they're getting back, and if they pay with a card, they want to know which card it is. And they get to work, they need to interact with people, right? Because it's a major part of work. So they want to know which person they're speaking to. And of course, reading is something that has to be immediate, and it has to be painless, and it has to be a joy to read. And we achieved that, and I'll show it to you in a second. And all this happens in a tiny device that you put on your glasses. And it has, let's see, it has a tiny camera in the front, it has a speaker in the back, there's a battery and compute unit, and everything happens inside this box. And nothing leaves. And this is critical. And it's critical nowadays that we all forgot what privacy really means, right? If you are a lawyer and you're in a peak of your career and your eyes start deteriorating, and you need to read a lot of confidential information. The last thing you need is some hacker, playing around with the data that or the letters that you're supposed to be reading. And this is critical. And when we started doing this, people say, oh, it's crazy, you can't do it, you have to have a whole Google farm of servers or something. But you don't. And we managed to pack all this functionality into this tiny device. And I'll show you a quick demo. Now, I have to warn you, the device is shy, and it's not designed to work on a stage, but it does. So what I'm going to do, I'm going to clip it onto my glasses. Now, we were supposed to connect the audio. No, you tell me. Okay. Can you hear? We can try this, but it might buzz. Volume max. Max? Yeah? All right. So imagine I'm in a restaurant, and I want to read the menu, and I can't. Did it ever happen to you? Did it ever happen to you? Can you help me? All right. Here's the menu. All right. Let's see. Now this is going to be tricky. Here we go. Okay, this is the menu. Can you read it? Oh, you hear that? And I can read. I can read this. Please lower your finger. Okay, it's telling me to lower my finger. Chicken with snow peas. Chicken with cashew. Is it right? Nuts. Right? And it happens to you. And it happens all the time. And this is, for a visually impaired person, this is how the world looks like. So you're in a place, and you know there's information there, but you can't get it. If you can't get it, you say, you know what, maybe I don't care. And when you think back to your school, I'm sure each and every one of you had this rowdy kid in class that wouldn't listen and would, but was a clever kid. It was a bad kid, but he would just said, why are you putting me in this room, right? And many of them went on to succeed, just like many other dyslexics. So, before we continue, is there any way to make this device better? Make it smaller. How about make it smaller? How about make the whole thing fit like this? So you can wear it like that, on your neck, and whenever you need it, you can put it on, and it can read to you, and it can recognize your friends, and it can tell you a lot of, all right. Usually I don't walk around with a mic. And it can tell you everything, and it's a device with the size of your finger, right? So you can see this. You see this? You can all try it. Look. And this can read, and it can recognize people, and it can help you through your day. And everything happens here, so there's no issue of privacy. There's no big brother, because everything is here. The device sees something, and it tells you what it sees, which is exactly what your eye is supposed to do. And this makes it a really, really useful tool, because there's no big brother involved. So we built a really clever and intelligent device. But it's intelligent in the sense that it gives you real information. This is critical, and a lot of questions come up these days about AI and deep learning and what can be done. And I thought, how do I explain the core ideas of intelligence to people which I assume not very technological in the scientific level, right? We all want to use the technology. We want to know what we're using, right? If I have a device, I want to know what the device does. I don't want to know, I want a device that does things that I don't control. And this is part of the problem nowadays. So let's think, what is intelligence, right? How do you define intelligence? It's not a trivial question. Let me approach it from a certain angle. Think about the Library of Alexandria, 300 BC. It's a semi-mythical building, and it was supposed to host between 40 and 400,000 scrolls, and it was the largest and most significant libraries in the world at the time. You can look at that building and say, wow, this is the smartest building in the world, because it contains all the answers that we have, right? Presumably. If there's a question, let's say I'm an Egyptian, I sit in Alexandria, I want to know if there's a cure for some disease. I can go to that library, I can speak to the librarian, help me find the books, read those books, figure out the answer, and then I'm out, right? So this building is clever. And you all must have one or two friends that are like that. There are libraries. And you ask them a question, oh yeah, they know, this is this and that. Now, jump forward 2,300 years, we have the internet. And the internet is the biggest and most significant data corpus of the modern world, right? And companies like Google managed to index way more data than that big library of Alexandria. They claim, what I found is 130 trillion scrolls. And is that enough? Do we add more to this corpus, right? Will it make us smarter? Will it make us smart enough? It's not clear, right? So we know way more, right? If you don't know something, you can Google it quickly. But is that enough? And I claim that it is not. And the reason is that memorization is a very weak form of intelligence. So our brains have a capacity, but that doesn't mean we have better solutions for things, right? And being intelligent, right? If you sit with a group of people, oh, he's smart, right? Why would you say it, right? So knowing a lot of things is definitely helpful, but it's not necessarily what you mean, right? What you need. What you need is a way to generalize. And the current state of AI doesn't do it, and I'll show it to you in two examples. First example is this. So let's say I'm Google, and I'm taking, lots of pictures of gorillas. And I release to my customers a feature, right? You show me a picture, I'll tell you what's in that picture. And then you get a picture like this. And then a guy tweets, and he says, Google Photos, you all beep up, my friend is not a gorilla, right? So what happened here is that we took 1 million pictures of a gorilla, and we show a new picture. Now we ask, is this a gorilla or not? Right? I don't know. maybe it is. And then you can claim, well, there's a bias, there's racism, but the bottom line is that the technology, and definitely deep learning, the way it is done today, does not really generalize. The best thing you can say is, well, I'll put so many pictures that the chances of you putting something which is very, very different is low. But it does happen, right? Now, for the more technical people here, I'll give another example. And this is the multiplication table. So, anyone here doesn't know the multiplication table? Quick, 7 times 8. Well, maybe you do. Right? But you all were forced to memorize it, right? And you want to memorize it. Why? Because it's a useful tool, right? So I did the exact same thing. I took a deep learning system and I told it, well, I want you to memorize the multiplication table. It's a figure, so I'll go quickly with you. So here, this is 1 to 10 and 1 to 10. And this is the error the network does. So without seeing any examples, I get a training error of 101. Okay, so on average, it doesn't do very well. Then I start throwing examples. I say, well, 2 times 3 is 6, and this and this and this. And the network quickly learns stuff. And you can see the error here. It's going down and down and down and down. And the network starts learning, right? So here is 7 times 3, sorry. Fairly quickly, it gets to 0. And it struggles. But look how many examples. 40 million, 50 million, 60 million. And it learns. And eventually, it'll get to a pretty good result. And it will know the multiplication table. Right? So here, let's see. Here, 7 times 4, no error. 7 times 5, no error. How about 7 times 8.5? Ooh, lots of error. How about 7.5 times 8? Right? Lots of errors. And you have no control in current state of what's going to happen there. And this is exactly the gorilla case. This is the gorilla. Google showed this picture of a gorilla, this picture, this picture, this picture. Some user comes and gives this example. And they have no control of what's going to happen. And if you run the exact same code, many times you'll get many, many different errors. And this is the funny thing about the current state of deep learning, and I hope this example illustrates it. Right, so here you get different types of error. Here is a nicer picture. Here's a network that I specifically showed how to do the multiplication table right, and it does it much better. Right, so it gets pretty good error. I mean, if you had a calculator that gives you this result, you'd throw it out because this is ridiculous. But it's way better than this. And it can be embarrassingly stupid. And this is something, and you saw it in the headlines. Now at OrCam, we are using deep learning, but we also mix it with other methods that we cooked in-house to make sure we don't have these mistakes. And this allows us to recognize things in a very reliable way. And once you do that, and you have a device that can understand in a reliable way what's going on around it, you get something like this. This is a part of our team. The device recognizes immediately some of the faces. As soon as it sees text, it can recognize it. It can do Chinese. There's like thousands of things it can recognize. And it figures out what it knows, what it doesn't know. And it does it pretty well. It does it in real time. And it does it in a tiny battery-operated device that's with you. And it tells you what it sees. So it can see and it can tell you what it sees. And it tells you, not anybody else. This is critical because without this, you get a liability and not a useful device and useful technology. So given technology like this, what do you get from customers, right? So I'll show you a few examples, right? So here's one from the internet a few months ago. Thanks to OrCam, I've just sorted out my freezer, not being able to do this for 17 years, right? Know what's in your hand, right? Just know what you're holding. And here's a recent one from 2 days ago I just found. We bought OrCam to our 23-year-old son who is blind. Great product. This is great to hear, right? I don't know these people, but they sound happy. I'll share another example of a lady that came to visit us quite a while back, and she was in the process of losing her sight. And she was talking about this experience, so it's interesting. Oh, let's see if we can get the audio. Is it working? No. Ugh. Wonders of technology. Anything? Let me go back. Let's try. This is, I'll use this interruption to just mention. So if you have technology that helps you and it's not with you, it's much less useful, right? And like in Jerusalem, we have the bus announce the stations for people who are visually impaired. And as a sighted person, you say, wow, this is a great feature, it helps everyone. But as a blind person, you say, wow, I can't believe it. It happens to me twice a week that I get on a bus and the system is broken and it doesn't work. But if it's with you, you know how to use it and you know how to make it work for you. And that's why we designed it this way. Anyway, so let's see if we are blessed with the sound. And if not, we'll skip it. Anything? Maybe the guys on top? I can hear it here. Well, you can't hear it, but she's very excited. And she's telling about how hard it is to be visually impaired, and she lives in the US, and all the money is the same color, and she puts stickers on the notes so she can tell them apart. Can you hear? Nothing, huh? Well, but she's happy. You can see she's happy, right? And this is just the ability to read. Oh, there we go.
Although most of their business comes from Brazil, their home country, ugly business.
Well, there we go.
Fantastic!
All right.
Fantastic!
Thank you.
$50, $50, certo?
50, let's see if it's better. Yes?
Green, all green. And I put mark color, yellow, green, orange, different notes. Preciso mais. Again.
$20.
It's not me.
All right. So let's see. So I assume, okay, if you can go to the next slide. So the next feature I'm going to show you is something that happens in all devices. All battery-operated devices have it, including your car. And it's the most useful feature on a phone. You know what it is? All right, you'll know in a second. If you can play it.
Wow!
Cool,
What
huh?
time is it?
You're asking it.
Awesome. What time is
Hey,
it?
Paul.
You're asking it.
Yes. Look,
Really?
I don't even have a watch on my wrist.
So even
Show
the
Paul
simple
how to do it.
No.
Show Paul.
information about what time it is. It's extremely useful. It's one of those things that people really appreciate.
Here are the glasses.
Okay.
Okay.
So
And like you're
it's
checking
gonna
your
be
wrist.
difficult, but I don't have a clicker.
Hello?
Oh,
What the time is it?
No, you have to do it like this. Show the device. You look.
all right. So if you want to create a useful wearable, right, it's something that has to be with me. I want to carry it. And it has to help me with something that I need. And it mustn't harm me, right? So if it's something that radiates all the time, and it's one of the things we forgot, right? You remember that phones used to have radiation and somehow they don't anymore? Just like smoking used to be healthy and it wasn't. So it mustn't harm me. It must be with me so I can want to carry it. And it must be available for me whenever I need it. And it has to interact with me in my natural life, right? So it has to be natural interaction. And it definitely must maintain my privacy because privacy is critical. And there's quite a few movies now coming out about the end of privacy, but it's something that's obviously very important. Now, as I finish, I want to talk to you about what's next. So we help a segment of society that has a clear need. What's next? And what's wrong with this picture, right? And I think the best way I found to describe it is a fairly depressing, overly depressing video by Moby. I don't know if you guys seen it. It's very nice. About our life, right? All of a sudden, it's as if life is so boring. Let me just look in my phone. Maybe something will happen there. But if you do business, right? You'll never close a deal without meeting your partner. you'll never do it because meeting face to face is so much richer and you get so much and life is amazing, right? And we somehow forget, right? And if you have kids, they're visually impaired just as well because, they'll just walk like that all the time. But life isn't, and life is exciting, and there's so many interesting things, but somehow, in our current temporary state of affairs, having a social network is actually a virtual network, and having a friend is a virtual friend. And people are, typical person has about 400 friends online, but maybe 2 or 3 friends or semi-friends in life. But the people who will help you are the people that are with you. And we wanted to help these people, which is all of us, with a device that helps me. So we called it My And this is a tiny device that you can clip on a shirt, and it helps you with your social network, your real network, your real interaction with people, so that your interaction, your physical interaction, is real. So I'm not going to talk much about it, but it's right here. And this is the device, and it will be out soon. And again, it adheres to all the rules that I stated earlier, that, it's a device for me, and it helps me. It doesn't harm me, and that's critical. And we believe it's going to be a great success and a great change to how people work. And in a way, we look at it as the next stage of evolution of our society, right? So it's a bit of a funny picture, but what it really says is, us, as a species, we made it so far, and we're amazing creatures. And the reason we're amazing is because we can interact with each other. And the better the interaction, the faster we can move forward and move forward together. And the MyMe is going to help us go to the next level where we meet a lot of people and we have to maintain a very complicated web of lots of relationships that our brains were not wired to. But it doesn't take our power, it helps us. Thank you.
A big round of applause. Thank you very much. Actually, the first question I have for you, what does MyMe do?
Okay. So I didn't speak much about it. It can analyze your interaction with your friends and how you do it and help you with it. And if you meet someone, you don't remember who it is. And I don't know, it happens to me a lot. I go to the kindergarten, I drop the kids, some other parent says hi, and I know I met them, but I don't remember their name. Or later on, I meet someone in the park, and I go to the park, and someone, it happened to me. A woman comes and says hi, and I say hi, and then 2 hours later, I realized she was my son's teacher. And if I'd realized it at the time, I could have had a meaningful conversation with her, but I didn't. It's a missed opportunity. So the first thing we want to do is help you with, manage your limited capacity for faces, right?
And does it talk to you, or how does it work?
So it can tell you if you have an earpiece somehow, which luckily very few people do.
Mm-hmm.
It can tell you on your watch or on your phone.
Okay, very cool. And that's coming out soon, you mentioned.
Yeah.
Very good. I want to open the round of questions. I already see one on the back here. I'll bring the cube back. Just the throwing things. Here you go.
Thank you. I have a question, or actually just two. How did you train the deep neural network to recognize all the situations? Because I assume one time it's a watch, the other time it's a
That's
paper,
right.
newspaper, something like that. And the second thing is, how do you really maintain privacy?
Okay. So it's part of our algorithms is to do it in a very efficient package, and as I showed you, it's tiny. It's a tiny package, and it's critical, right? And it's critical because it has to be with you. If it's big, it's cumbersome, you're not going to want to use it. And it takes, it's a mixture of hardware and software, but you really want to know what it is that you want to get. Deep learning seems to everyone, oh, well, I just take a pile of data, I stuff it in there, I run it on a GPU, and something happens. My GPU would finish this battery in, 3 seconds, right? We'll suck it out. The second thing about privacy is a very good question. How do you maintain privacy? And what you have here is like a little mini pipe that takes in pictures, converts them into sound, and speaks them out. It doesn't need memory. It doesn't need memory. It doesn't need communication. And in our first version of the device, there was no communication at all. There's nothing there. Here we enabled connection to the phone because it helps with upgrades and stuff like that, but it's not for processing. And in our first version of the device, there was no communication at all. There's nothing there. Here we enabled connection to the phone because it helps with upgrades and stuff like that, but it's not for processing. And it's fantastic because it gives you immediate feedback. It doesn't need to send something, get it back, and maybe it works, maybe not. But this is the secret sauce, right? This is what makes it work.
So for my understanding, so you say you're processing the whole analysis on the device itself.
Yeah, just
That's
like the video I
point,
showed.
right?
Yeah.
Okay. But then how did you do the learning? Because the learning is a very intensive, computer-intensive process. Somehow you need maybe to adapt your device for the future and so on. So you need to have some agents who may be connected to some knowledge to do more learning, and even improve for the future, right?
Right.
So somewhere you need to do this learning.
Right. Okay, so let me see if I understand. But our customers get software updates, and every update gives them better and more functionality, and that's how
I think the question relates also, if I understand correctly, to where do you originally train these algorithms from? I mean, do you take data sets that you purchase? Do you collect them yourself? I think that's sort of the question that you're asking. Like, where did you get started, right? Because, I mean, you showed the gorilla example, and, I'm sure Google has plenty of examples of gorilla pictures. Right. They had that database. What data did you use as the ground truth to train these algorithms?
So we cannot compete with Google with the amount of resources they throw on problems like that. But the point I was trying to make is that even if you have a million times more, it's not enough. Because if you don't know what you want to do, you have no idea what's going to come out. And the space of all possible scenarios is way bigger than the number of atoms in the imagined universe, right? It's not enough. So it's not a brute force, right? And people treat deep learning as a carpet bombing. You say, well, I'll just bomb the whole thing, something will come out. But James Bond does it, one bullet, right? And if you know what you're looking for, you get it, and you do it way more efficiently. And this is critical, right?
And so that's what you guys did with OrCam, with device.
We use a lot of ideas from deep learning, but we do it in a smarter way that enables us to do it in a much more efficient way to extract it and then control what the mistakes are.
Excellent, perfect. Do we have any other questions? We have time for about 3 more. Somebody in the middle, somebody up top. It's always hard to see, so just you can yell down if you're on the top and you have a question. Perfect. Well, I think that's it. Thank you very much for making it out here. Thank you very much, guys. A round of applause. For you as well, we got you two awesome wearables. This thing I think it fits all your rules as well. Well, it's useful, doesn't harm you.
All right.
It doesn't talk to you though. But we went to find something else. This does talk to you. It's not very. It's not smart yet, but maybe in combination with that. So thank you very much for coming out here. Thank you, guys. Another round of applause. Folks, perfect. So that's it for this morning's talks. We are about to move on to lunch. I'm sure all of us are hungry. I got super hungry when he was showing that menu, so I'm actually really glad that we're about to eat. So folks, 1:45 is the time to meet out there for the lab, so do be on time. If you have any other questions, please do let me know, and we'll see you all again here tomorrow for further talks. Ladies and gentlemen, thank you very much. Enjoy the labs.